Thank you, everyone, for joining us on this episode of Manufacturing Talk Radio. I'm Tim Grady. I'm here with host Lou Wise. Lou is the president of All Metals and Forge Group and the sponsor for Manufacturing Talk Radio. We certainly invite anyone who'd like to be a sponsor for Manufacturing Talk Radio to let us know, and we'll get your name out on the airwaves. Joining us today is Christopher Huynh. Christopher is going to talk to us about some very interesting things that he's developed. He has quite a track record with well-known names that you have heard of. Christopher, thank you for joining us on Manufacturing Talk Radio.
Thank you, Tim.
So give us an idea of what you're involved with now after you finish. Just a little introduction of yourself, where you've been, what you've done. I was very impressed to read it.
Maybe I start from the beginning.
That's good.
Okay.
Christopher, I just want to tell you, it's only a 30-minute show.
Okay. Well, you tell me when to stop then. I guess a fun fact about me is I came to the country as a refugee child back in 1979, and then moved very soon after that to Silicon Valley. It was, of course, we had no idea, but I was very lucky to have moved there. Here, at the very beginning of the PC revolution. And I picked up hacking, and I have not stopped ever since. So that's if you remember nothing else about me, that's what it is. But I've had a long and varied career. Did my undergrad at Berkeley and PhD at Stanford in semiconductor manufacturing. So I know a thing or two about building clean rooms, and also that was part of a startup that was of the initial manufacturing wave in Silicon Valley. Before it was all offshored, called contract manufacturing. We were making PC boards and so on. And the company was eventually sold to Selectron. I went off to Hong Kong to become a professor. I started the computer engineering program there. So today, when you look at HKUST, Hong Kong University of Science and Technology, there's a department of ECE, Electrical and Computer Engineering. That CE was my start. But I've also left the university and started a couple of companies in Asia. Did system integration with Netscape back in the early days of the internet boom. Sold the companies and then moved back to the Valley. And my friends at Google came calling and helped launch Gmail, Calendar, Doc spreadsheets, which a lot of people know as Google Apps today. But the last 6-7 years, I've been doing this thing in the space we call big data / machine learning. And in between this project, a big company decided to acquire us, Panasonic. So most recently, I've been running global AI as part of that team at Panasonic, reporting to the CTO in Japan. And this latest startup that I've launched with pretty much the same team we've been working together for 7 years is all about helping to advance industrial AI for industrial companies like a Panasonic, like an Intel, various industries, manufacturing, avionics, automotive, and so on. And I'd love to talk about that.
Well, all that being said, why don't you tell us about your latest venture in dealing with industrial organizations and what it is that you do for them?
Yeah. Well, maybe I start with the hard-won lessons that we learned after we became part of Panasonic, which is, I think a lot of people know the Panasonic brand as a consumer brand, but it turns out most of the Panasonic business today is in the, what the company likes to refer to as the B2B, but really, selling to industrial companies. So cold chain, the cold supply chain, now how a fish gets from ocean to your dining table, of course, it has to be kept refrigerated the whole way. Panasonic is a global giant in that. If you fly and you look at the LCD screen, 70% chance that you're looking at a Panasonic avionic product, including Wi-Fi and so on. In the automotive space, a lot of the instrument displays on, when you drive a car, that's also produced by Panasonic. And of course, if you drive a Tesla, you may know that all those batteries are manufactured by Panasonic. So when we were acquired, we were, as I told Lou before, what I call a bunch of geeks with algorithms, right? And we were tasked with applying those algorithms to this vast empire of Panasonic, which was undergoing a major transformation. The 100th year anniversary was 2018. We ran into headwinds very quickly, and it's a very interesting problem, right? Coming from a place like Google, I assume that there's plenty of data, and so if you know anything about machine learning, AI, the fuel for machine learning is data, and we're talking massive amounts of data, right? The idea there is that if there's enough data, the algorithms, the machine learning algorithms can learn enough of the patterns so that it can project into the future and make predictions like, is the compressor likely to fail over the next 2 months, so that you would proactively replace it before it fails. What we found is that for physical industries like manufacturing, the vast amounts of data that is there is actually not quite suitable for machine learning. In other words, it's not the right food for that animal. And so we were basically unable to make an impact for the first 6 months until we realized there was one key insight. And it is that there's a whole lot of domain expertise in these companies that from the machine learning world, like I'm talking, coming from this side, we tend to ignore that human expertise, that human knowledge, and we want to just give me a lot of data and I'll figure it out. But having run into that, what I call the small data wall, and then almost reluctantly, leveraging the human expertise, we found that turns out to be the key to execution. And so today, what my company does, we're now out of Panasonic as a team. We still have Panasonic as a customer, but what we focus on is building algorithms, techniques, and technology and platforms that helps companies like Panasonic encode human expertise into the AI systems. So it's not just machine learning alone, but machine learning as guided by, as initiated by human knowledge.
So let me ask you, the product and or service that you're providing, is this primarily for larger corporations, or are you geared for middle size and or lending your expertise towards the smaller companies who have a long way to grow?
Yeah, I would say in principle, anybody can use this, right? Any company that has a lot of human expertise, domain expertise, and have, thinking about machine learning, AI, can that help me with applications like predictive maintenance? But have essentially not succeeded at it because of this small data problem. It's a very interesting problem. People don't realize that in fact, there's not enough data. Now, I would say that the larger companies are in a better position to take advantage of this because they tend to have also the right personnel, right? But I think the range of, by the way, it's an open source project. So that's an element where companies can just take that software and implement it themselves as well. Right.
While we're talking about that, why don't you give us your URL for our listeners to be able to go see you on the net?
Okay, well, the company's name is Itomatic, right? It's just like automatic, but starting with AI. So if you go to itomatic.com, you'll see a lot of what I'm talking about. Okay,
that's great. Yep.
Christopher, give us a sense of some of the projects, because I know that when people hear AI, their head probably immediately jumps to the Terminator movies and machine taking over man. Where is it really going, and what have you been working on to reassure us?
Yeah, we can take off from there. There's a question. So this is about 2017, when I went to London, there was a first AI conference, sponsored by O'Reilly. And after I gave the talk about, the lessons learned, taking AI into a place like Panasonic, there was one question from the audience that, essentially, are you replacing a lot of, line manufacturing people? And I thought about that question a bit. I realized that everything that we had done up to this point and really since is almost the opposite of that. So far, the successful applications of AI in industrial companies have been more about where there's not enough scalable, if you will, to use a term from Silicon Valley. There's human expertise, but there are not enough of them, right? Because of the scale of the deployment is so large. And these experts, to be very blunt, this expertise is dying, right? Because young people today, right, they prefer to go to college and get some computer science degree. Software is eating the world, right? But this physical industry that requires hands and brains sort of connected, there are not enough people, right? So my answer to the question at that London conference is that it turns out what we're trying to do is we're trying to scale the expert, right? I'll give you one example, a predictive maintenance case. This is for Japan. Japan has these large supermarket chains, right? There's a 7-Eleven is a supermarket chain in Japan, Family Mart, and so on. They want to have predictive maintenance for refrigeration, in these supermarkets, so that a failure, an unplanned failure, doesn't take down the entire operation. And all of Japan, the service organization that is supporting these markets has about 3 experts that could look at sensor data and make sense of it. So how do you support that large market? The only way you can do that is to somehow codify the expertise, the knowledge that people have, and these people have accumulated that experience over 3-4 decades. Anyway, so that's an interesting perspective that we learned we're actually not in the business of replacing human labor as much as scaling human expertise.
Tim and I have been doing shows now for quite a while, a lot of it having to do with the skill gap and all the things that you just mentioned about the tribal intelligence and being able to collect it, collaborate it into a program so you don't lose all that intellectual data. And you're right, and it actually winds up creating more job functions than less.
That's right. Yeah. Right here in the US, a Panasonic acquired company, Hussmann, Hussmann, you may be familiar with them. Again, also in the refrigeration space. Their number one problem today is they cannot get enough skilled service personnel to go out and maintain the equipment, right? And it pays really well. And so guess what one of their solutions is, other than applying the AI technology that we're trying to do, is that they're literally setting up schools, right, themselves, so that they can attract enough people to get into this profession, or to maybe to return to this profession. Right?
Well, that's interesting, because Tim and I had a guest on about 2 years ago. It was a company up in New Hampshire, where 2 companies. That's right. New Hampshire, right? Between these 2 companies, unrelated, had serious problems of getting help. And they didn't even have enough people in the state. Yeah. So they wound up putting together a school. And they shared the responsibilities, they shared the training, and they wound up bringing in people from other states, because you could get a training degree from them and get a job. The only proviso, if you remember, Tim, was that they were not allowed to steal employees from one another.
Right.
Yeah, I mean, these skilled people are getting more and more precious and more rare, here in the US, what with, a lot of the offshoring we've done, in the last, 30, 40 years.
Christopher, where do you think that offshoring is presently going? Are we beginning to onshore? Is it a zero-sum game? What's really happening there if you have an idea about offshoring?
Yeah, well, I think it's a very current topic, right? It turns out now we're realizing there are considerations other than pure, capital and OpEx costs, right? Even national security considerations, right? Or even something as simple as what we're talking about, the skills that are needed just to service equipment. If you think in terms of changes in deltas, I definitely see a sign that is pointing back onshore from the U.S. perspective, right? For various reasons, not least because China is getting more expensive as well, right? As the economy develops, the cheap labor that we were counting on, for as a primary reason for offshoring is become less and less significant. So I think certainly in high-end manufacturing industries that people, I come from that. That was my PhD, semiconductor, right? In the last couple of years, people realize, okay, well, this is actually a critical physical industry that we can't just software our way out of, right? So there's certainly a big trend toward building very large scale semiconductor manufacturing, back here within the U.S.
Well, Christopher, your approach to AI is fascinating, and I'm equally fascinated to hear that, as you correctly identified, the loss of expertise simply to population aging is so critical that you've identified a way to begin to capture that knowledge. So how is it being used by some of your clients?
Okay, I'll stick to the predictive maintenance example, right? Predictive maintenance in the purest sense is trying to answer this question. Can you, on a daily basis, can a system on a daily basis, tell me over the course of, say, the next month, right, of all of the equipment that I have, all the sensors and all the actuators that I have, out in my fleet, which are the top 100 I should look at because they are likely to fail, right? Is the compressor in the case of refrigeration equipment? Is it the filter and so on? If that ideal can be reached, it is so much better, certainly so much better than reactive maintenance, which is fix it after it's broken, right? So you could have hundreds of thousands of losses already. It's even better than preventive maintenance as well, because preventive is just go ahead and replace everything periodically. So very likely you're doing things that are unnecessary. Predictive maintenance is very sharply focused on things that are most likely to fail. So if you think about it from a technical perspective, and machine learning AI, the way that I would help people relate to it is nothing more than pattern recognition, right? Humans, we do it so naturally and so well that we don't think of it as predictive analytics. But if I throw a ball at you and you catch the ball, you're doing very complex predictive, artificial intelligence, natural intelligence, right? So predictive maintenance can be thought of as can we get machines, right, to look at these sensors long enough that after a while they can sort of forecast the behavior into the future. Now, so that's the basic idea. When you actually apply machine learning algorithms to that particular problem, you realize that you run into a problem pretty quickly, which is in order for algorithms, right, to learn enough about failures that they can predict when failures are going to happen, they need a lot of examples of past failures. Like when I say a lot, I mean not tens or hundreds, thousands, millions, right? And so this is the problem. You can collect a lot of sensor data, but in terms of collecting what in the machine learning world we call labels, right? The actual label of actual failure, that is very small data, right? So the conclusion of that observation, that's the wall we ran into, is that we actually have a small data problem when it comes to, say, predictive maintenance in these physical industries. We can easily identify patterns that fall out of the normal, but we cannot tell what the failure is going to be. And it turns out in order to predict or to observe and say, hey, it's likely to be the compressor, that still requires a human expert who has a lot of knowledge that are outside of that data. That's the key insight. When you have a 2-decade, 3-decade, 4-decade, long expert, they've seen a lot of things more than just, you may think that the data is massive, but they've seen a lot more. They've seen the variety of equipment, they know physics or they know engineering and so on. So it turns out in order to accurately predict what is going to go wrong, we call it fault prediction, we need to encode that human expertise. And so that's one very large class of examples of where human knowledge is so useful. In fact, I didn't give you the sort of the headline of the technology we work on. We call it knowledge first AI, right? Not data first, right?
Right.
It's knowledge first AI.
We've been talking to a lot of companies who are facing the problems that we've been talking about. And some of the smaller and medium-sized companies, they're recognizing that they've got this problem of losing intellect, losing knowledge. And when somebody wants to retire, they give 30, 60-day notice and they're gone. And now you have a 22-year-old who doesn't know quite as much as the person who's with you for 40, 50 years. So what a lot of these companies have been doing now, when they are exposed to this potential, they offer incentives to people to stay, don't leave, stay, and we're going to get you somebody and you're going to train them on the job.
Apprenticeship.
Right. And while they are learning that, there are apparently a fair number of software programs out there that you feed information as you're working. And as you talked about, you're collecting all this data and the machine learns how to do it. And then the person you're training knows how to do it from the machine or the software. So it's a very interesting dilemma that we're in right now. And I think people are beginning to get it, that it's not so much that you're going to lose jobs, as many believe, but you're actually going to be gaining jobs.
That's right. Yeah, doing other things, right?
Yes.
Doing more advanced things. I think there's your what you say reminds me of a story that I think I can share, because it's not confidential knowledge.
Be my guest.
You may know that Panasonic is really behind the Gigafactory, right? That makes batteries for Tesla. In the early days of setting that up, so the idea with any manufacturing is, Intel has this phrase called copy exact, right? You have a successful plant and you copy every measurement and just do it exactly. And so there's a sort of a similar copy exact from the manufacturing operations in Japan that are making very good, high quality, high yield battery to Nevada. And it turns out, other than the growing pains, there was a particular problem with human expertise, right? The people that could be hired into Gigafactory around there did not come from, like I said, we've had 30 years worth of sort of lack of tooling and manufacturing expertise in the US. And so yields were extremely low, right? And it turns out most of it was basically just human error, right? Or human knowledge, knowing exactly, what a good battery looks like, a good sheet coming off of the line looks like, and so on. So the punchline here is, it turns out one early solution was to import a lot of the Japanese manufacturing operations people, right, into Nevada. And it takes a while. Exactly the example that you show, it's through kind of a apprenticeship system. Like, a lot of the skills were transferred to essentially local people in Sparks.
It's interesting, different parts of the world have different methodologies on how to deal with this issue. And Germany has a very interesting program, and they've had it for decades and decades. And that is that when you go to public school in Germany, you are 2 days or 3 days a week, you're involved in uh, uh, craft development, manufacturing, making things. And the other 2 or 3 days, you are doing liberal arts and math and sciences. So they're getting a fuller education in terms of their future careers. Here in this country, up until recently, parents always want their kids to go to college. Go to college. You want a degree, you'll be the first in the family to get a degree. Well, it doesn't work that way because you wind up with a $200,000-300,000 college debt. You have to go get a job, but you're not going to earn $100,000 a year the first couple of years you're there. You're going to make $40,000 or $50,000 a year, which is quite different than what's going on in the craft world. Take, for example, to be an underwater welder, which is a very dangerous job. And I think it's considered the most dangerous job in the world.
Wow.
You can make $150,000 plus stock options, plus healthcare, plus pension, and so on and so forth. So I think parents need to be taught. We've talked to a lot of people about this, that parents must understand that going to college may not be the answer all for your bright little kid.
Yeah.
You got to give them full exposure to lots of different things.
Yeah.
And then that brings us to where you are now.
Yeah, individual choices aside, which is important, I think in the aggregate, right, like an economy, we cannot afford not to have the physical side of it, right?
Oh, sure.
We're still, you and I and Tim, we're still physical beings, right? We still eat, we still drive cars, we still fly planes, and so on.
Right.
So we need to have that. And if, Silicon Valley is actually not unaware of this. There are various movements. There's the maker movement, actually people making things, right?
Mhm.
And you may have heard, firms like Peter Thiel actually has challenged, people to, people of the right profile to drop out of college and get a grant from the firm, $100,000, so they can go build something, right? But I like to think that cyberspace up to now has been kind of an aberration. The only reason we went cyberspace was because the early computers that we built could not really connect to physical space. And so we call it cyberspace.
Right.
As soon as we have devices like iPhones and with sensors and actuators and so on, these devices are connecting back to the physical world. I think there are local reasons that physical is important.
What I found interesting is that Japan literally made the robot world.
Yes.
They lost a whole generation of males as a result of the Second World War, and they developed the robot. And they are now the #1 producer of robots in the world. And I just read recently, they're coming out with a whole new series of robots that are called soft touch robots. If you touch them, they feel like a human.
Yeah. You're one of the few people that I see realizes the connection between Japan's aging population and the advances in robotics. In fact, it was exactly the reason for that. Japan saw that it was, as a country, getting older.
Yes.
And not enough replacement birth, right? Like it's the case for most advanced economies. And so their solution was robotics, right? That's why they invested so early on, right?
And you're right. Not many people know about this.
Right. There is a direct connection.
Oh, directly. And the United States, we do have a fair amount of robotic type machines that are doing jobs that humans used to do, could do, would have done, but now they have them monitoring these machines. So one person can monitor 3-4 machines. You're getting almost 4 times the volume of production. So there's a lot of great things going on. And, you know, when I was a kid growing up, I used to always think, I was born in the 40s, 1940s. And I always wondered, you know, what's it going to be like in the 2000s? You know, and I was, you know, 10 years old in 1953, was 50 years later. Well, never thought it would be like it is, but it's really an interesting time.
Yeah.
And
2001 Space Odyssey, right?
yes, absolutely, absolutely. Star Trek. Um, Christopher, I appreciate your being here. I'm sorry that we've lost connection with Tim. He's probably hearing us. I don't know what the problem is, but not technology works all the time, right?
Well, I've enjoyed the conversation. Say hi to Tim for me.
Well, thank you very much, and I appreciate it. And good luck with the projects that you're working on. And I just want to say thank you for everyone listening to us today, and listen to all of our podcasts at Jacket Media Co. or Manufacturing Talk Radio. And we will be, actually, we have a couple of new shows coming up, and it's strange that Tim brought it up before about offshore reshoring jobs to the United States. One of the most well-known person in that world is a gentleman by the name of Harry Mosier. And Harry's going to be doing a show with us calling it Mosier on Manufacturing. And we're going to be starting with that in another week or two. Harry's a great guy. He's been honored by many in that segment of our economy and our world. But folks, listen to all of our shows. And, we appreciate your listening. So Christopher Wen, thank you again for joining us. And we'll be talking to you again soon, I hope.
Thank you, Lou. Love the jackets.
All right, thank you. If you join enough shows, you get one for free.
Yeah, we agreed on 5, right?
Okay, thank you. Bye-bye.
Take care.